Okay, question 11. A newspaper vendor in Singapore is trying to predict how many copies of The Straits Times they will sell. The vendor forms a model to predict the number of copies sold each weekday. According to this model, they expect the same number of copies will be sold each day, right? So that's the first kind of important thing. They are saying the same, they expect the same number of copies each day. To test the model, they record the number of copies sold each weekday, and they get this data, right? So it looks like maybe on Wednesday, Tuesday and Wednesday, no, actually Friday, they sell more copies, a lot more copies of their newspaper, but this is just a sample. So we need to run a test, a goodness of fit, well, it says it here, goodness of fit test at the 5% significance level is used to determine, on this data to determine whether their model is suitable. Okay, so first, part A. Find the estimate for how many copies the vendor expects to sell each day. Now remember, they expect to sell the same number of copies each day, but these are not the same. So how many? We just need to get an average. So the average of this will just be 74 plus 97 plus 91 plus 86 plus 112 all over 5, because there's 5 days, and that will give us, well, whatever it gives us. Now this is only worth 1 mark, guys, so you don't even have to show that working, but I did anyway. Plus 91 plus 86 plus 112 equals that, divided by 5, 92. Okay, so 92 is what they expect to sell each day. So if you like, the expected frequency, the expected number of sales is 92 here, 92 here, 92 here, 92 here, and 92 there. Okay, B, part I. Write down the degrees of freedom for the test. So the degrees of freedom is, if you remember for goodness of fit test, guys, it's just n minus 1. So it's just 5 minus 1, which is 4. So it's just write down, I'm just going to write down 4. Then, part I. Write down the conclusion to the test, give a reason for your answer. Now, hang on, I skipped a little bit here. So it's a goodness of fit test at the 5% significance level, and the critical value for the test is 9.49. So they actually give you the critical value here. H0 is the data satisfies the model, and H1 the data does not satisfy the model. So what's the conclusion? Do we accept the null hypothesis, or do we reject do we reject or do we fail to reject, is what I should say. Well, we need to run the test. So what do? I go in and I, let's close this, guys, because I don't know what, I do not want to save that. Okay, now I'm going to put these numbers in. So I'm going to put I'll put my 74 here. I'll put my 97 here, my 91 here, my 86, and my 112. And then beside it, all of them, I'll have 92. So 92 here, 92 here, 92 here, 92 here, 92 here. Now I'm going to call these guys, this is, let's just call it copies sold, and let's call this, hang on, invalid. Okay, let's just call it copies, and let's call it this expected. Now what's important is that you make sure that one is the expected and one is the one that actually happened. Then we press menu, statistics, stat tests, and we are going to run a chi-squared goodness of fit test. There we go. The observed, yeah, that's actually the word I was looking for. You've observed and expected. So the observed is the one that I've called copies here. That's just the number of copies that were actually sold. And the expected is the expected. Degrees of freedom is 4. We've already done that. Results in C, that's fine. Press OK. And we get a chi-squared value of 8.5, 8.543. 348. So actually let's write that down. I'm going to say chi-squared equals 8.543, 8.543, and the p-value is equal to 0.07358. 0.07358. Now, what's the conclusion to the test? Well, there's two ways you can answer it. You can say because the chi-squared value, so I'll write it over here, as chi-squared equals 8.543 is less than, it is less than 9.49. So because your chi-squared value is smaller than the critical value, then we cannot reject the null hypothesis. There's not enough evidence to suggest that we should reject it. So we fail to reject null hypothesis. Remember, they don't like to say we accept the null hypothesis. It's just we can't reject it on this evidence. You could also say, because the p-value, because it's a 5% significance, so you could also say, I'll just write, you only have to put one, but I'll put them both, also as 0.07358 is greater than 0.05, the same reason we fail to reject, because it's like, it's not totally unreasonable that you would get these results. If you were expecting to get 92, 92, 92, 92, 92, you might get these results. The same way, if you were, I don't know, flipping a coin 100 times, it's not unreasonable that you'd get 52 heads and 48 tails, even if the coin is fair, obviously. Okay, so that's it, guys. Hope that makes sense. 6 marks there. Again, these are questions like there's nothing really tricky to them if you know how to run a chi-squared goodness of fit test. If you don't, obviously you don't have a clue what to do. But this is not like a really, really crazy, challenging, hard question. It's just testing. Do you know how to do it? So, guys, make sure you know how to do a basic chi-squared goodness of fit test, and obviously all your other tests as well. Okay, that's it.